So if you want to convert from scientific notation, what you're simply going to do is you're going to take the value that you begin with, and you're going to move your decimal point to the right or to the left n spaces. If it's a positive number, to the right. If it's a negative number, to the left. So if we take this first example, we're multiplying times 10 to the 4. We're going to take this decimal point and move it 4 places to the right. So 1, 2, 3, 4. Fill each of these gaps with zeros, and that gives you your number 699, 2 zeros. So that would be your solution. If you're moving it in the negative direction, what you're going to do is you're going to take your decimal exactly where it is. It starts right after the 4. I'm going to move it 6 units in the direction that it states, a negative direction. So I'm going to move it 1, 2, 3, 4, 5, 6 places. So there's the new decimal. Fill each of these sort of gaps here with a 0. And so this would be my simplified form, 0.0000403. If you're moving it in the other direction or converting it from the other form where they give you the written out form, the decimal form, and they ask you to find the scientific notation that is a more efficient way to express that, what you're going to do is you're going to take just your digits, place the decimal after the first digit, and then you're going to multiply it by 10 to the power of. And again, if you just kind of work backwards from the way that we did this, if my decimal was after the first digit and I move it 1, 2, 3, 4, 5, 6, 7, 8 places to the left is a negative, and so I get times 10 to the minus 8 for my power. And even if they get you a number that's really not conducive to the scientific notation, you can still express it in that form. So here we write our digits, 6161, place a decimal after the first. Again, that guarantees that it fits this condition. And then identify here, if this was where the decimal was, 1, 2, 3, it gets moved 3 units to the right. So times 10 to the 3 will give it that form.